So this video lesson is having a look at molar mass, and then we're going to do some conversions that involve two steps with moles. So we're going to first start by talking about molar mass. And so from the periodic table, when we look at a card on the periodic table, so we're just going to look at carbon to start off with. And so carbon's atomic number is 6. And its atomic mass on the periodic table is 12.01. Okay, and so atomic mass of carbon is 12.01. And the units that we use for atomic mass are actually atomic mass units. So we call them AMU, so atomic mass units. Okay. If we had, say, a molecule, so say we had a molecule like CO2, its mass would be 1 carbon atom plus 2 oxygen atoms. So a carbon atom is 12.01 and oxygen is 16.00. And so in total, that would be 44.01 AMU. And this would be molecular mass. So this would be the mass of the entire molecule if we're looking at having just 1 carbon atom and 2 oxygen atoms. Now, a tricky thing about the mole is that if we actually have 1 mole of carbon atoms, it will actually be 12.01 grams. And so all of our atomic mass units, if we have 1 mole for that atom, then we'll actually have that many grams of that atom. Okay, so 1 mole of carbon atoms is going to equal 12.01 grams because that's its atomic mass from the periodic table. If we had, say, 1 mole of oxygen atoms, same thing, only it would be 16 grams because that's oxygen's atomic mass from the periodic table. Okay, and so what that means is that we have something called molar mass. And so molar mass is the mass for 1 mole of an atom. So of a specific type of atom. Okay, so if we have a compound like, say, calcium chloride. Calcium chloride is CaCl2. So there is 1 calcium atom and 2 chloride atoms. Okay, so 1 calcium has a molar mass of 40.08, and that's grams per mole. And then chlorine has a molar mass of 35.45 grams per mole. And those just come from the periodic table. And so if we were to add those together, we'd end up with a total molar mass of 110.98 grams per mole. And so that's the molar mass for our calcium chloride. Okay, so all we have to do is use the masses from our periodic table, and we have to add them up according to how many atoms we actually have. So we used 1 calcium, but there were 2 of our chlorine atoms in that formula. Okay, if we look at a formula like, let's do something like Na2SO4. So if we look at a formula like this, there are 2 sodium atoms, there's 1 sulfur, and there are 4 oxygens. Okay, sodium is 22.99 grams per mole. Sulfur is 32.06 grams per mole. And oxygen is 16 grams per mole. Okay, but there needs to be 2 of those sodiums, 1 of the sulfur, and 4 of the oxygens. So that gives us a total of 142.04 grams per mole. And so that's the molar mass for our sodium sulfate. Okay. Now, since the unit for molar mass is grams per mole, we can actually use that to go between mass and moles of a substance. And so we can actually use it as a conversion factor. Okay. So we're going to start with an example here. So say I have 2 moles of calcium, and I want to find out what the mass of calcium is. Okay, so I'm going to start out with my 2 moles of calcium. I'm going to have to multiply by a conversion factor here. Now, I want to use the molar mass of calcium from the periodic table. So from the periodic table, I know that there are 40.08 grams for every 1 mole of calcium. And so my moles will cancel out, and I'll be left with grams as my unit here. So I would do 2 times my 40.08. So it'd be 80.16 grams. Okay. Now we can use this with any type of substance. It doesn't have to be just an atom. We could do it with a compound if we wanted to. So say we had 3.6 moles of, let's do sodium chloride. So of NaCl, and we want to find the mass. So what mass would that be? So I'm starting with my 3.6 moles of NaCl. I need to multiply by that conversion factor. I know I'm going to put the 1 mole on the bottom, but I need that molar mass for sodium chloride, and I can't just read that from the periodic table because there's 1 sodium atom and 1 chlorine. So sodium is 22.99, chlorine is 35.45, and so the total is 58.44. So that's my molar mass. And so that's the grams that's going to go on the top here. So then I can cancel out my moles and be left with grams. So when I do that, my 3.6 moles of sodium chloride is 210.4 grams of sodium chloride. Okay, I can also use the conversion factor to go the other way. So if I have a mass of something, I can use the conversion factor to help me calculate how many moles. So say I have 25 grams of, let's do a more complicated formula. Let's do magnesium hydroxide. And so I want to know how many moles. Okay, so we're going to start with our 25 grams, and we're going to multiply by that conversion factor. I want to turn it into moles, so I'm going to put the 1 mole on the top. But now I need the molar mass for my magnesium hydroxide. So magnesium is 24.31. And again, remember we're finding this on our periodic table. Oxygen is 16. And hydrogen is 1.01. But keep in mind, there are 2 oxygens and 2 hydrogens. So we get a total molar mass there of 58.33. Yeah, 58.33. So then that's going to go in our conversion factor so that we can cancel out our grams and be left with moles. So our 25 grams, we're going to divide by our 58.33. And so 25 grams of magnesium hydroxide is 0.43 moles of magnesium hydroxide. And so we can use that conversion factor the same way that we've been using conversion factors to go from moles to particles. We can use this to go back and forth between mass and moles. Okay, and the only thing we need is we need to have that molar mass. And so this conversion factor, this number down here, or the number on the top of the conversion factor, right? That is always going to be molar mass for the substance. So if it's just an atom, that comes directly from the periodic table. If it's a compound, you have to make sure that you add up all the atoms in the compound to get that molar mass for that specific substance. All right, so we're gonna move on from there, and we are gonna look at doing some two-step calculations. So these two-step calculations, we are going to actually go from particles to moles, and then from moles to mass. Or we're going to go backwards. We're going to go from mass to moles, and then from moles back to particles. Because particles and moles have a conversion factor that we can go between, and so do moles and mass, which means we can go from mass to particles by making a stop at moles. So we are going to start right into some practice here. So I have 8.03 times 10 to the 23 atoms of fluorine, and I want to know the mass. Okay, so I'm going to start with my number that I have, 8.03 times 10 to the 23 atoms. And I need to multiply by a conversion factor that is going to get rid of my unit of atoms. So that conversion factor should be the fact that 1 mole is 6.02 times 10 to the 23 atoms. So we're going to use our conversion factor that has Avogadro's number in it. If I just did that, I would be left with moles. But I don't want moles, I want mass. So I am going to add a conversion factor. And this conversion factor, I'm going to allow us to calculate going from moles to our mass. So I want to put 1 mole on the bottom. This conversion factor is going to be molar mass. So for fluorine, the molar mass is 19 grams per 1 mole. And so that will allow me to cancel out my moles, and I'll be left with grams as my unit once I do that calculation. So in my calculator, I do my 8.03 times 10 to the 23. I divide it by my 6.02 times 10 to the 23. Don't forget, put this number in brackets when it's on the bottom. And then I'm multiplying by 19. And so that's going to give me 25.3 grams. So my 8.03 times 10 to the 23 atoms of fluorine ends up being 25.3 grams. And I just used multiple conversion factors in a row. If you want to do it separately, you can, but being able to use 2 conversion factors in a row is actually a lot easier. And so you don't have to stop and write down the number in the middle in terms of your calculation. You can just do the entire calculation at once in your calculator. All right, let's try another one. Only this time, let's start with mass, and let's try and figure out how many atoms. So here I have 350 grams. And let's use a compound in this case. So I have 350 grams of, say, potassium chloride. And I want to know how many molecules that is. Okay, so I know the mass of my potassium chloride, and I want to know how many molecules. One of the first things I want to do is make sure I know the molar mass for potassium chloride. So potassium is 39.10 and chlorine is 35.45. Remember, those come from your periodic table. And so we're just going to do that addition. So the molar mass for potassium chloride is 74.55 grams per mole. Okay, and so we're going to convert this 350 grams of potassium chloride into molecules. So I'm going to start with 350 grams, and I want to multiply by a conversion factor that's going to allow me to get rid of grams. And so that's going to be my molar mass conversion factor. So for potassium chloride, I know 74.55 grams is 1 mole. And the reason I put the conversion factor that way is so that grams will cancel out. Grams on the top, grams on the bottom. If that's all I did, I'd be left with moles, but I want to know how many molecules. So now I'm going to use my conversion factor with Avogadro's number. So I'm going to put my 1 mole on the bottom and Avogadro's number on the top. So 6.02 times 10 to the 23, not 32. It's the second time I've done that today. And this is going to be molecules because that's what we're counting. And so then my moles is going to cancel out, and my unit that I'll be left with will be molecules. So when I go ahead and do that math, my 350 is divided by 74.55, and then multiplied by my 6.02 times 10 to the 23. So I end up with 2.83 times 10 to the 24 molecules of my potassium chloride. Okay, let's try that one more time. Let's go backwards. So let's use carbon dioxide this time. So say I have 3.28 times 10 to the 23 molecules of carbon dioxide, and I want to know the mass of carbon dioxide. So first thing I want to make sure I have is my molar mass. So carbon I know is 12.01, oxygen is 16, and don't forget there's 2 of those oxygens. So molar mass for carbon dioxide is 44.01 grams per mole. So we're going to start with this 3.28 times 10 to the 23 molecules. And we're going to multiply by a conversion factor to get rid of molecules. So that means 1 mole is 6.02 times 10 to the 23 molecules. Remember, we're putting molecules on the bottom because we want to get rid of molecules. But if we just stopped there, we'd only be left with moles. So we want to continue using a conversion factor that's going to get us to mass. So I know that my 1 mole of carbon dioxide is going to be 44.01 grams. So I'm going to be able to cancel out my moles, and I'll be left with the unit of grams once I do that math. So I'm going to do my 3.28 times 10 to the 23. Divide by my 6.02 times 10 to the 23. Don't forget to put this in brackets on your calculator. And then multiply by 44.01. So I'm going to end up with 23.978. So we're going to round to 24.0 grams. So I ended up going from molecules into grams of carbon dioxide. Okay, that's it for those 2-step calculations. Now, there's a ton of practice. Try as much practice as you need until you can do this backwards and forwards without having to think about which way you're going to use the conversion factor and which conversion factors are available to you. So make sure you try a lot of that practice. You don't have to do all of the practice, but make sure you try enough so that you feel comfortable